Okay, ladies and gentlemen, we're going to talk today about an intro to trig transformations. If you want to follow along in your packet, the page in the packet which matches this will be this page right here. But I'm going to work on a different screen, just so I'm not writing over the top and sort of following along on some things. And what we're going to do is we're just going to relate what we know about the features of sine and cosine graphs. But today we'll just talk about sine. I'll talk about cosine as well as what we've done in the past with transformations. So we'll still be using our information on reference angles and values of sine and cosine. But let's break down a couple of things, and there's 4 questions for you to answer at the end, and a little bit of homework, which you can probably start in class and maybe even get done. Okay, so first of all, we talked the other day about the graphs of sine, cosine, and tangent. So cool too. Now, we're going to not focus on tangent right now. We're going to deal specifically right now with sine and cosine. And I'm going to start just by talking about sine. I'm going to draw a regular sine curve, which looks just like that. Okay? And we know it goes on in both directions forever. And a sinusoid has 4 main features. And this we haven't talked about. And if you don't remember these terms right now, I'm going to be absolutely fine with it. The first term is, in Algebra 2, it's called the midline. And in here, we're going to call it the sinusoidal axis. Sinusoidal axis. And it's just the line that the sinusoid wraps around. Okay? The next feature we're going to talk about is the amplitude. And we talked about that a little today. That's the distance from the middle all the way up to the top. The third feature we're going to talk about is what we call the period. And the period is how long it takes for one cycle of the graph to complete itself. On a regular sine graph, let's use a different color. That one cycle takes 360 degrees to complete. And then the next feature we're going to talk about, and when I use these words, it might seem a little bit weird. Eventually, we're going to take these sinusoids and we're going to shift them left or right, okay? We're going to shift them. So imagine I grabbed this sinusoid with my hand and I pulled it in this direction. This graph is going to move kind of like this. It's going to shift itself over, okay? It's actually been displaced. It's been moved over. This distance it's been moved is going to become what's known as the phase displacement. Do I expect you to memorize these words right now and know them all? No, I do not. But we're going to talk about how these words relate to transformations. And if you remember, there were 4 main transformations we worked with in the past: horizontal translation, vertical translation, horizontal dilation, vertical dilation. There's basically 4 main transformations. 4. And I'm going to go back to here. And on the features of the graph, I have 1, 2, 3, 4. So if you were going to guess what was going to happen, what do you think those 4 transformations are going to match up to? Sorry, those 4 terms of the sinusoid are going to match up to? Anyone? Yes, that's right. Each one is going to match up to a different transformation. Now we'll connect them together later. We're going to talk about these right now, and I'm going to show you what each one would look like. So the first one I'm going to draw is the following. I'm going to write an equation, y equals 2 sine theta. So we're using theta instead of x. I'll put parentheses there to help out. Now what type of transformation is this? This is a vertical dilation times 2, because the 2 is multiplied on the outside. So that would shift the graph up. Sorry, not shift the graph up. I said that. Could have been $1 if you got me. It's going to take the original sinusoid, which is in blue, and it's going to stretch it to be twice as big vertically. Is it perfect? No. But that's pretty bad at the bottom, isn't it? But you get the idea. This is going to be a stretch, and it's going to dilate it too. Okay, let's go to the next one. Our next transformation is y equals 2 plus sine of x. Sine of theta. And that is going to be vertical. It's outside. Translation plus 2. So this is going to vertically move the graph up 2 units. If this is my original sine graph, after the transformation, it's going to be like that, shifted up 2 units. Okay, now we're going to go ahead and do some things horizontally. Y equals sine of 1/2 theta. Okay, so what that means is going to happen, this is going to be horizontal. It's multiplied, so it's dilation. The opposite of 1/2, it's going to be times 2. So this means that if I had my graph, I don't know why I'm drawing it so low, and I had my original sine graph, it's going to be horizontally dilated to make it twice as big horizontally. So if I was to graph it, the height isn't going to change at all. Oh, not perfect. Let's try that again. Not perfect, but we can live with it. I think it's going to look something like that. It's going to stretch it out horizontally. And then the fourth one, y equals sine of theta minus 10 degrees. I'm using a degree sign here because I'm working in degrees. Well, this is going to be horizontal. Translation plus 10. So what that's going to do is it's going to shift the original sinusoid, there's the original one, horizontally 10 degrees. So if this spot was at 0 degrees, this one is now at 10 degrees. If this high point was originally at 90 degrees, it is now at 100 degrees. Okay, so I've looked at 4 different transformations, and I remember I have those 4 words, okay? So let's go back and see if we can connect each one of them up. Let's start with this feature right here. If I vertically dilated the graph, one feature of the graph changes. It's the height from the middle to there. What feature is that? That is amplitude. T-U-D-E. So my first question to you is, which feature of the sinusoid matches up to a vertical dilation? And here's the answer you can put down for number 1. Vertical dilation changes the amplitude. So let's go on to question 2. Now you may think you know what all 4 questions are, but you might not. Next is going to be a vertical translation plus 2. On the original, the sinusoidal axis was here, and after that vertical shift, the sinusoidal axis shifts up that way. So a vertical translation changes the sinusoidal axis. So question 2 is, which feature of the graph changes when you do a vertical translation? Okay, feature number 3, a sine graph. This is the horizontal dilation times 2. Well, the original period of the sine graph from here to here was 360 degrees. What do you think the period of this new sinusoid, the blue one, is? Did you say 720 degrees? If you said 720 degrees, you are correct. It was a horizontal dilation, the opposite of 1/2, so it got twice as big, and it went to there. So the period relates to the horizontal dilation. And last but certainly not least is the shifting of the graph. Now, the point that's on the sinusoidal axis that starts originally is right here, okay? And now all I've done is I've shifted it over. I've done what's called a phase shift, okay? By moving the graph over, I have a new starting point for my sine. It no longer starts at 0, it starts at 10. The horizontal translation is the phase displacement. So my question for number 3 is, what features do a horizontal dilation and a horizontal translation change? See, you thought you had the new 1 through 4, but I gotcha on that one right there. And my last question, number 4, is going to be the following. There's a word that you may see called frequency. The frequency of this sinusoid which takes place over 360 degrees, is 1, because there's one sinusoid in 360 degrees. And you can get this one wrong, it's fine. What do you think the frequency is of this sinusoid, where this distance is 360 degrees? That's your fourth question to put on there. Now, your homework tonight is in your packet. It is these problems right here. Hold on, we gotta find them. There they are. All you're doing is identifying, there's no sketching going on. You're identifying the transformation or transformations that are going on. All I want is a direction, a type, and then the factor. Times or add or subtract. So I know what's going on. Now, I'd like you to take a picture of your answers of your the 4 questions. Please send that to me via Remind. If you don't have your phone, have someone else send it. If you want to finish your homework now and send it to me as well, you won't have to turn it in tomorrow. If you have any questions, work with the rest of your class, and good luck.